Thank you everybody for attending this conference talk on XcodeSurgery, eliminating recompilation for your build variants. My name is Kenneth Poon and this is my profile, email, GitHub, Medium and LinkedIn pages. About me, I am a principal software engineer at SPDigital. I like to bring agile development into the iOS development space, and I am a Tech Talk contributor in the iOS Dev Scout meetup group. Now, for today's topic, we are going to focus on optimizing building different app flavor or variants. In a typical workspace setup, from our source codes, we can build one variant like the developer build, in this example pointing to the dev instance of the mail and auth server. And later we can prepare another variant for staging. In the staging build, we will point our corresponding API to the staging domain instance. And finally, developers can prepare a production build for Apple App Store submission. Sometimes we need to build custom flavors to enable certain permutation of features. So for the build time, assuming one app takes m minutes, 4 apps will approximately take 4 m minutes. So when we have n build flavors, the total build time grows linearly, even though there are no logic changes in the source codes. And build time increases as developer writes more code. So when we have more codes and more flavors to build, this setup becomes not so scalable. Possible common reasons for long compile times is when we rely on build setting dependent variables like xconfig and preprocessor macros. For example, Xcode will create separate build directories for different build configuration. In this screenshot, when we build debug, release and staging, Xcode will recompile the same target 3 times. For preprocessor macros like hex if defined, the build process in Xcode will trigger a source code dependency check and recompile all dependent codes. To sum it up, changes that affect build settings trigger recompilation. So for today, I would like to introduce to everyone here at iOS Conf SG 2021 a command line tool I wrote called XcodeSurgery. The focus of this tool is to reuse compiled binaries when building targets. And this helps to eliminate unnecessary recompilations for different build variants. XcodeSurgery does not require any code refactoring to use the tool. Hence, after this talk, you can immediately employ this tool and start benefiting on the build time savings in your projects. However, you may want to adjust your code base to further optimize the build process. Let me first share about installation. XcodeSurgery command line tool is available as a Swift package at this GitHub repository. You can install this Swift package via Mint. Mint is a package manager that installs and runs Swift command line tool packages. You can use this blue command to install Mint. Using Mint, you can install XcodeSurgery with this command. XcodeSurgery requires 4 easy steps to integrate into your project. Step 1. Create a new app target, and we will refer this as the destination target and the original target as the source target. Step 2. Copy the build settings from the source target over to the destination target. Step 3. Add a preparation build phase for source target. And step 4. Add a transplant build phase for the destination target. To go into details, step 1, create a new target. We will be using this Swift UI repository to demo XcodeSurgery. So this is an open source project that I found on the internet, and I am using this to demonstrate how easy it is to integrate XcodeSurgery into any projects. In this example, the source target is Movie Swift. We will create a new app target called Movie Swift Client and this new target will be referred to as the destination target. In step 2, we will copy the build settings from the source target over to the destination target. The destination target will take on all build setting properties and will become the pseudo clone of the source target. Here's a GIF animation on how to copy the settings over to the targets. First, we select the source target and then use Command A to select all and Command C to copy. Then we select the destination target and use Command V to paste the values. To repeat, we select the source target, Command A to select all, Command C to copy, and then we select the destination target and use Command V to paste the values. For step 3, we will create a new run script placed at the last build phase step and insert the XcodeSurgery prepare command. We will need to input a temporary working directory, target build directory, and target name. In step 4, similarly in the destination target, we will create a run script as the last build phase step and use the XcodeSurgery transplant command. We will pass in some Xcode build environment variables as well as the path of the working directory and the name of the source target. Building the app is very straightforward. We will just need to build the source target once and we can proceed to build the destination target. For deploying the app, first, you can run the destination target and observe that you can deploy a clone app of the source target. You can modify the destination target build settings with different bundle identifiers, code signing instructions, and provisioning profiles to create different build variants. Observe that the source target binary does not get recompiled. So some of you may be asking, how can I configure my app variants? So don't worry, I will come to that later in the talk. Now let's do a live hands-on demo of XcodeSurgery and go through these 4 steps. Number 1, create a new app destination target. Number 2, copy the build settings from the source target to the destination target. Step 3, add a preparation run script. Step 4, add a transplant run script. This is a Swift UI open source project I have downloaded to demonstrate how anyone can easily apply XcodeSurgery into your projects. To save time in video recording, I have pre-built the main iOS app target, Movie Swift, for the iOS simulator. We will refer this as the source target. Let me run the app to show you how this app looks like. I have made some changes to the project and added some CocoaPods third-party libraries to load up the total build time of the app. And this is a beautiful movie app showing movies now playing at the cinemas. In the build logs, it shows the total build time taken as 146 seconds. If we were to instruct our continuous integration server to create 2 build variants, it will approximately take 290 seconds to build. Now let's apply the XcodeSurgery steps and see how much time savings we can get out of it. So the first step we need to do is to create a new app target. And I will name the target as Movie Swift Client. And we will be referring this as the destination target. Now let's run the client target to see how the new app looks like. And it shows a very simple Hello World application. After creating the destination target, the next step requires us to copy the build settings from the source target over to the destination target. So now we select the source target, head on to build settings, And we use Command A to select all, Command C to copy, then we select the destination target, and Command V to paste the values. For the next step, we will go to the source target and create a new run script with the XcodeSurgery prepare command. In this command, we will provide the arguments for the working directory, target build directory, and target name. For the next step, we will go to the destination target. Similarly, create a new run script with the XcodeSurgery transplant command. Here we will input Xcode build environment values, and we also need to provide the path to the working directory and the name of the source target. Before we build the movie Swift client, let's first build the source target. The build process will now use XcodeSurgery to prepare for the transplant command. Next, we will build and run the destination target. Using the new script, we have now sudo cloned the original app onto the destination target. Now let's inspect how long it took to create the destination target app. And the total time taken is about 2 seconds. We can apply variant values for different build flavors using xcconfig. In my project, I have created 2 xcconfig files containing the variant variable called home nav title. I will be changing the title of the navigation bar as a visual example. And I'll be using one xcconfig def showing the navigation title as def now playing at the cinemas, and for the other configuration staging showing staging exciting movies for you. In your own projects, your xcconfig files may specify various API URLs your build variant would use. To apply the variants, we need to go to our project info page and select the xcconfig file for the corresponding build configuration. So for the debug build, I will be selecting the def xcconfig file, and for the release build, I will be using the staging xcconfig file. So first, let me open up xcscheme to ensure that we are selecting the correct build configuration. Let me select the debug build. Let's build and run the debug version of the app. So now you can see that the title of the navigation bar has changed to def now playing at the cinemas. Now let me build and run the release build of the app. And now using the release build, we have changed the title of the navigation bar to staging exciting movies for you. Now let's summarize the time taken to build our apps. So the total time taken to build 2 variants will be about 147 seconds plus 147 seconds. And after using XcodeSurgery, the time taken to build two variants is 147 seconds plus 2 and plus 2 seconds. So this is approximately how much time savings you will get by simply using XcodeSurgery build process. Now let's head back to the slides where I will explain what is happening under the hood. To better understand how XcodeSurgery works, let's inspect how Xcode builds and packages iOS apps. In here, I will run a custom script to open target build directory at each build phase step. Before compilation, we can open up the app folder and we will observe that Xcode will place a provisioning file. This happens when we build and directly install the app onto our development devices. After compilation of source codes, Xcode will place the compiled binary in the app folder with the target as its file name. At the copy bundle step, Xcode will place resource files like localization strings, images, and info plist into the app. After completing the entire build phase, Xcode will sign the app and place the code signature inside the app folder. Depending on your project setup, the app may also have frameworks embedded in the frameworks folder. And here I will show you what is happening when we execute the XcodeSurgery process. For the source target, Xcode will compile the source codes and copy all needed bundle resources, listing items like assets and plist into the app folder. When we run the XcodeSurgery prepare command, the command line tool will make a copy of the source app and place it in the working directory. After that, Xcode will proceed to sign the app. For the destination app, XcodeSurgery transplant command will copy and replace the binary and all relevant bundle resources from the source target app in the working directory to the destination target app. At this point of time, Xcode doesn't perform any integrity check on the binary and will proceed to code sign the app. This process will work when we build variants for the iOS simulator, direct install on device, and archiving for distribution. Why is this possible? Firstly, there is no integrity check performed by Xcode between build phase steps. The application linking step assumes files have not been tampered with. Code sign is only performed after completing all build phase steps. And you may be wondering if this is a new feature on the latest version of Xcode. Interestingly, I have discovered and have been using this technique since 2016. XcodeSurgery may not always be needed or applicable in situations where the project requires different compile optimization modes for each build configuration. There isn't a need to build multiple variants at the same time. In some project team setup, only a certain flavor is built where new commits are pushed onto specific branches. And probably the extra recompile time is currently not significant enough. XcodeSurgery works best when variant variables are held in feature files. Here's my humble suggestion on one way of achieving this. Firstly, migrate all variant variables like domain instances, feature toggles to a file such as plist. Then before starting the build, generate a random symmetric encryption key and use that key to encrypt the feature files. Next, generate a source code containing the encryption key so that the app can now use the same key to decrypt the encrypted feature files. After building, the encryption key can later be disposed of and no one other than the app itself have the key to decrypt the feature files. In the transplant command, you can use the argument files to inject to indicate which feature variants you want to use for the build. Other notes on XcodeSurgery. So what's in the name? The XcodeSurgery process, which requires us to open up the app folder and perform the replacement of files, reminds me of surgeons opening up two bodies and having to perform an organ transplant. And that's how I coined the term 5 years ago. Hey, the idea is 5 years old, but the repository looks very new. My original code was written using shell scripts. For this conference talk, I decided to rewrite everything in Swift and took time to research on Swift Package Manager, Swift Command Line tool, so that I can share this knowledge with all of you here today. This tool works for building variants on simulator, installations on device, and archiving for distribution. I will be starting work on the transplant process for Axis extensions. And here I have reached the end of my talk. You will enjoy build time savings using XcodeSurgery. I will encourage everyone here today to install and try it out. The tool is available at this repository. Feel free to reach out to me and share with me your thoughts on this new tool. Thank you.